Hi, I'm Peter, an engineer at WorkOS. I'm excited to talk about events and keeping your data in sync with WorkOS. Today, I'll focus on user management. As you onboard organizations, over time, they'll add users, they'll update users, perhaps in ways that grant that user greater control, and users may get removed as well. It's crucial your application reflects those updates accurately. This problem is commonly solved with webhooks. WorkOS supports webhooks too. We can send webhook updates to your app. But webhooks come with hidden complexity that make it more difficult to keep your app accurately up to date. Webhooks are not guaranteed to be delivered in order. They're initially sent in order, but may be routed differently to the webhook consumer and arrive in a different order than they were sent. Problematic in this case, as the webhook for user update arrives before the webhook to create that exact user. Also, no app is perfect. Even a short outage of your webhook consumer can result in a failed webhook delivery. The webhook isn't lost. WorkOS will deliver it later. But in this case, that exact same create user webhook is delayed even further, exacerbating the problem of receiving webhooks out of order. Scale can also lead to problems. A large set of updates, like onboarding a large organization, can trigger a lot of webhooks. This flood of webhooks can overwhelm your webhook consumer and lead to delivery failures that will need to be reattempted later. As a quick recap, keeping data synchronized with webhooks is challenging because updates may not arrive in order. A flood of webhooks can overwhelm your webhook consumer. If webhook delivery fails, your app needs to await redelivery, and once delivered, there's no way to programmatically retrieve that webhook again. Additionally, since your webhook consumer is an open endpoint, webhooks require an extra HMAC signature verification for security. Our solution to these problems is an API to retrieve the stream of updates in order. Your app makes API requests to WorkOS, and WorkOS responds with a list of events. Let's dig into this exchange. When your app requests events, those events are returned in a consistent order, eliminating the problem where your app might see an update before its corresponding create. Your app controls its cursor in the event stream as a parameter when requesting the next batch of events, and it can request those events when it's ready for them. You can also rewind your cursor and retrieve those events again. The pace of event retrieval is controlled by your application. These events contain the same content as our webhooks. In consistent order, your app controls the pace of consumption. You can replay events that your app has already seen. And since your app is using API keys, there's no extra signature verification necessary. I'm going to hand it over to my colleague Sherry for a demo integrating events.
Hi everyone, my name is Sherry and I'm an engineer here at WorkOS. Today I'm going to be stepping through a demo of the WorkOS Events API. The Events API is available through a number of our SDKs, and in this case we're going to be taking a look at the Python SDK. So here we have a sample app that displays directory data, while an events consumer, a separate thread in this case, is going to be updating the app with any directory changes through the Events API. So let's take a look at how it works. So the first thing that we're going to do is some basic configuration. Namely, we're going to update the WorkOS client with the API key and the client ID obtained from the WorkOS dashboard. Next, we're going to be setting up a polling thread. This is going to be calling a function called pollEvent, which we'll step through momentarily, and then proceeding. Then we start the thread and start the app. Pretty simple. So let's jump to the code for the pollEvents function and see what's happening in the consumer. So the first thing that this function is doing is setting a cursor. While this one is set locally, we can set this through a cache or a database. Next, we're going to be entering a loop. Within this loop, we're going to be calling the WorkOS client, which is going to be fetching a list of events that have occurred after a cursor. Then, for every event that we receive, we're going to be processing it by using some handler function. Now, we have a handler function for the user created event, so let's write one for the user updated event. So we'll create a function called process user updated event that's going to accept an event and a database object. Then within our app's context, we're going to be fetching the user from the database if it does exist. And we're going to be making sure to filter by the directory user ID, which we'll pull from the event itself, and then we'll fetch it. And we want to make sure that we can actually fetch this for updating. Then, if the user does exist, we're going to be processing it by updating the name and the updated at timestamp, both of which will fetch from the event itself. So let's update the updated at timestamp as well. Perfect. And then we'll commit our change. Otherwise, if the user does not exist, we're going to return. Perfect. Now let's go back to line 57 and update to actually handle the desync user updated event in this case. So here we're going to be putting in the function we just created, passing in the event and the database. Awesome. Now that we have our actual function, let's see how it looks like in the live application. So here on the right side, I have the server output, which is watching out for any events that I've received. On the left side, we have the application. Now in the application, I'm going to update my name from Sherry to Strawberry. And I'm going to do this in my IDP, and we should see the change reflected within our app. So I'm going to go ahead and do that now. And momentarily, we should see an event coming in and received. And we do. So now we should see my name updated from Sherry to Strawberry. Perfect. That's all for this demo. Thank you so much for watching.